the viewers, we have an interesting question on the board. We have to solve this. Um, what we solved in our last videos, I'm using the word videos because it's much, there was nothing like power. I can still recall we solved things like z is equal to 1 plus I, z is equal to square root of 3 plus I. All these are given without power. So, but this is given. I'm going to tell you the difference between this question and this. Let me clean. Solution. Recall that the formula for finding polar form is this. This is our formula for polar form. But when the power is given, have you seen the power? The formula now changes to z raised to power n is equal to Rn into cos n theta plus operator I sine n theta. When the power is given, we are using this formula. But when the power is not given, we are using this. What is the difference? What if the question was just given, just like z is equal to 1 plus I square root of 3? We are using the first formula to solve. You get my point? But the power, when the power is given, we are using formula 2. So let's solve. Still the same step, but what changes is the n. So solution is step 1 is always the modulus, the square root of a square plus b square, which is equal to, recall that this is a and this is my b. My a in the question given is 1 and my b is square root of 3. This is 1 square plus square root of 3 raised to power 2. So r is equal to 1 plus 3, which is equal to what? Square root of 4, which is equal to 2. We are done with that. That is step 1. Then step 2 is that the argument is always equal to what? The tan inverse of b all over what? A. So theta is equal to tan inverse of my b is what? Square root of 3 divided by what? 1. If we use your calculator in our last video, we were solving things on this and I show you how to solve. So the tan inverse of square root of 3 divided by 1 is equal to 60 degree. Is equal to 60 degree. If you check your calculator, if you punch that in your calculator, you have 60 degree. 60 degree. Now let's substitute that in the formula. Z raised to power 3, have you seen now? Z raised to power n, that is 3, is equal to, my r is what? My r here is 2 raised to power what? 3. That is n, r raised to power n. Then bracket open, or if you want to use parentheses, there's nothing wrong, into cos what? 3. 3, n is 3 times what? 60. 3 times 60 degree, have you seen? Plus I sine the same thing, 3 times 60. Let me just change it to 180 because 3 times 60 is 180. Let me change this one also. Okay, let me just leave. So 0 raised to power 3 is equal to 2 raised to power 3 is 8 into, this is cos 180. 180 degree plus operator I sine of this. That is in degree. But we can, from here, we can change it to radian. In our last video, we convert this. This is the formula for converting from from degree to radian. So this and this cancel. We have it to be pi divided by what? 3. So you can keep this answer also in radian, in the sense that z raised to power 3 is equal to what? 2 raised to power 3 into what? Cos 3. Have you seen? N is 3 times my theta is what? My theta here turned to pi divided by 3. Have you seen now? In the sense that this and this cancel, plus because of space, operator I sine n is what again? Look at n. N is 3 times what? Pi divided by 3. This and this cancel again. So you can keep your answer in this format. Z raised to the power this is equal to 8 into what? Cos. What is remaining here is just pi plus I sine pi. Remember that pi is also equal to 180. So if you want to go extra mile, you can just leave, because if you want to press cos 180 in your calculator, this is 180 cos 180. Cos 180 will give us something like minus 1. This is minus 1. Cos 180 is minus 1. Then sine 180 is 0. So this can be minus 1 plus 0. That is minus 1 times this. That is so minus